Right. Beside finding the determinant, cofactor is also useful to find the adjoint. Okay, where the adjoint is useful to find the inverse matrix. Okay, so we use adjoint to find or to calculate the inverse matrix. Alright. So what is adjoint? Adjoint is the transpose matrix cofactor. Okay, so adjoint is cofactor. You have the matrix cofactor. You transpose it. That is adjoint. Okay, so for n by n matrix, okay, 3 by 3 matrix and so on. Okay, finding the adjoint is just transpose the cofactor matrix. Okay, let us look at the first example. Let's say you have matrix A that is equivalent to minus 4, 7, 1, 6, where this is the similar example from the previous slide. Alright, and we know already what is the cofactor of matrix A. Alright, so in order to find the adjoint of matrix A, we just transpose the cofactor of matrix A. Okay. Alright, we have the cofactor of matrix A. Okay, so we got this from the previous calculation. Okay, from the previous slide. Okay, so this is our cofactor A. To find adjoint A, so we just transpose this matrix, which is the cofactor matrix. Okay, transpose it. Do you still remember transposition of the matrix? Okay, so you swap the column become the row, and the row become the column. So okay, so now you transpose this matrix, means T mean transpose. Okay, so now our first column will become our first row. Okay, so transpose the whole column, the whole first column become the first row. So 10, 30, 54. Okay, and then transpose the second column become the second row. Okay, 43, 17, 53. And then transpose the third column become your third row. Okay, now this is called adjoint of matrix A. So as simple as that. Okay, for second example, let's say you have matrix B equal to this matrix. So follow the first step. Okay, you need to find the cofactor of matrix B. Okay, in order to find the cofactor, you need the minor, and then you proceed with putting the positive and minus 1 sign to your minor, so you get cofactor. Okay, right, so the result from the from finding the cofactor, we will get cofactor B equal to this. Okay, so I'm sorry because I didn't show the way of finding cofactor B, just to shorten a little bit this lecture. Alright, so you can review, okay, the way of finding cofactor from the previous slide. Okay, right. So what is adjoint B? It is just transpose this cofactor. Alright, so you get this. Okay, so now if I choose to transpose the column, the row. Okay, when I choose to transpose the row must become the column. Okay, see, the second row transpose to the second column. The third row, we transpose it, it becomes the third column. Alright, so this is our adjoint B. Okay, so just remember that adjoint of the matrix is the transpose of the cofactor. So as mentioned before, okay, adjoint is used to find the inverse matrix. Okay, so if you have matrix A and there exists inverse of the matrix, okay, multiplication of these two matrices, okay, equal to identity, okay, or inverse multiply with matrix A, also you get identity. Then A minus 1 is called inverse of matrix A. Okay, so A is called identity matrix. A multiply with inverse will produce identity matrix. Okay, first let us look at the inverse matrix of 2 by 2 matrix. Okay, for 2 by 2 matrix. Okay, following the definition, if our matrix A multiply with the inverse of matrix A is equivalent to I. Okay, this is I, not 1. I mean identity matrix. Okay, do you still remember identity matrix? If 2 by 2, it is 1 0 0 1. Okay, this is 2 by 2 identity. If it is 3, so it will become this. This is also identity matrix for 3 by 3 matrix. Okay, this is for 1 by 1 matrix. Okay, so if you multiply the A with its inverse, you will get the identity matrix. Then the A negative 1 is the inverse of A, where the determinant is not equal to 0. Okay, so inverse only exists whenever the determinant is not equal to 0. Determinant the determinant of matrix A that is not equal to 0, this is called non-singular matrix A. Okay, so matrix A is non-singular matrix if the determinant is not equal to 0. If determinant of matrix A is equal to 0, matrix A is called singular matrix and A inverse does not exist. Okay, are you clear? Right. So please take note to the important things that I mentioned here. Okay, about the singular and non-singular. Okay, you must understand this. Alright. Okay, so let us look at the inverse for 2 by 2 matrix. The inverse of 2 by 2, the inverse for the matrix, okay, regardless of their order, whether it is 2 by 2 or 3 by 3, okay, is the same. So the inverse of matrix A or any matrix B, C, D, and E or so on, okay, the formula is 1 over the determinant of matrix A times the adjoint of matrix A. So to find the inverse, you just hold to this formula. Okay, right. Now we go to the inverse of 2 by 2 matrix. Okay, we apply the same formula. Okay, and remember how to find the determinant for matrix 2 by 2. Okay, it is this. Okay, determinant of matrix 2 by 2. We must make sure that the determinant is not equal to 0. Okay, we must make sure of this. Alright, for inverse A to exist. If you get determinant of matrix 2 by 2 equal to 0, means that A inverse does not exist. Okay, so A does not have an inverse. Okay, please remember this. Alright, so how to find the adjoint for matrix A 2 by 2? It is you swap the position between A and D. Okay, and you multiply negative to B and C. Okay, once again, you swap the position between A and D. So D will become your first element, first row, first column, and A will become the second element, second column. Okay, so you swap the position. While for B and C, you just multiply with the negative. Okay, so it becomes negative B if B is positive, and C, negative C if C at the beginning is positive. Alright. Let us look at the example of finding the inverse matrix for 2 by 2 matrix. So let's say if you have matrix A like this. So in order to find the inverse of this matrix 2 by 2, okay, it is equivalent to 1 over the determinant of matrix A. You multiply with the adjoint of matrix A. So first step, find the determinant of matrix A, which is A multiply with D. Okay, so 1 times 0 minus with multiplication of B and C, which is 1 times 2. So you get minus 2 for the determinant. Okay, so second step is find the adjoint of matrix A. For 2 by 2 matrix, you will swap the position between A and D here. Okay, so it becomes 0 and 1 here. And then you multiply with negative 1 to your B and negative 1 to your C. So negative 1 minus 1 multiply with 1, it is minus 1. Minus 1 multiply with 2 is minus 2. Okay, so our inverse of matrix A is 1 over the determinant. What is the determinant? Minus 2. What is our adjoint? Our adjoint is 0, minus 1, minus 2, 1. Okay, so you can leave your answer in this form or you can multiply it inside. So you get 0, you will get half, you will get 1, you will get minus 1 over 2. Okay. Okay, next example. If you have matrix A, 2 by 2 matrix, and matrix B is this, which is 2 by 2 matrix. Okay. You need to show that B is the inverse of A. Okay. We know that A multiply with inverse A will get matrix identity, right? So that we can declare that our A minus 1 is the inverse for the A. Okay, so if we want to show that B is the inverse of A, we need to show this. Okay, so B is the inverse of A. So B is inverse A. So now if we change this, okay, into here, okay, we have A, and what is our A minus 1 here? A minus 1 here is B. Okay, so we must show that A multiplied with B will get matrix identity, which is 1 0 0 1. Okay, so we multiply A and B here. Okay, and make sure the matrix that we get from the multiplication is 1 0 0 1. Once we can show this, we can say that B is the inverse of matrix A. If we fail to prove multiplication of A and B equal to identity, we cannot declare that B is the inverse of matrix A. Okay. Alright, so let us multiply this A and B. So we have minus 3, 1, 4, 2 multiply with 1 over 5, 2 over 5, minus 1 over 10, minus 3 over 10. Okay, we do for this first. Okay, minus is 3 over 5. Plus with 1 multiply with this is 2 minus 5. Am I doing the correct thing here? This one multiply that. Oh, so minus is plus here. Okay, so 1. Next is 4 multiply with that is 4 over 5. This is minus 2 times 2 is 4. 4 minus 4 over 5. Okay, and next we multiply 3 with this. Okay, minus 3 multiply with minus 1 over 10 is 3 over 10 plus with 1 multiply with 3 of minus 3 over 10 is minus 3 over 10. Okay, so 4 multiply with minus 1 over 10 is minus 4 over 10. Plus with 2 multiply with minus 3, it is minus 6 over 10. Okay, so for this is 5 over 5. This is 0. 3 minus 3 is 0. 4 minus 4 over 5 is 0. Minus 4 minus 6 is 10 over 10. Okay, so we get 1 0 0 1. So it is proven that we can conclude that B is the inverse of matrix A. So we're done with inverse for 2 by 2 matrix. Now let's go to finding the inverse for 3 by 3 matrix. Okay, so there are two methods to find the inverse for 3 by 3 matrix. Okay, so similar to the determinant of 3 by 3 matrix, you have two ways to find the determinant. Same goes to the inverse now. You also have two methods to find the inverse. So the first one is by applying the formula 1 over determinant of A times the adjoint. Okay, so when you look at the adjoints, you know that you need the cofactor. Okay, so because adjoint is the transpose of the cofactor. Alright, and the second one is by using ERO method, which is elementary row operation. Okay, so the idea is transforming the augmented form of A of identity matrix to identity matrix to the inverse. Okay, so we look at this one by one. Okay, we go to the first method, which is the cofactor method, by applying this formula. Right, so same thing apply. You must make sure that your determinant is not equal to 0. If determinant equal to 0, A inverse does not exist. Okay, so this is the formula. A inverse equivalent to 1 over determinant of matrix A times the adjoint of matrix A. Okay, I have two examples here. Okay, I will just show one solution, which is for example A, and I leave example B for you to solve it by your own. Okay, but to save times and shorten the recording, okay, uh, I have ready the solution for you. Okay, but don't worry, just follow my previous way of finding all the terms involved. Okay, so now finding the inverse by using the cofactor method. Alright, so first step, you need to find the minor. After you find the minor, okay, you multiply each of the minor, okay, element with the positive and negative sign. Alright, and then you get your cofactor A. Okay, so from here you need to find the minor for M11, M12, M13, M21, M22, M23, M31, M32, M33. Okay, where this is minor of matrix A. Okay, once you find the minor, okay, so remember minor is the sub matrix of the corresponding element that you delete. Okay, okay, I find the right color. Okay, once you find your minor, you transform it into this matrix and then you multiply with positive 1, negative 1, positive 1, negative 1, positive 1, negative 1, positive 1, negative 1, positive 1. So you multiply each of positive 1, negative 1 to your minor and then you get the element for your cofactor. Okay, you transform all here. Okay, the multiplication of each of these sign. Okay, you get your cofactor. Okay, cofactor. Once you get your cofactor, okay, remember we need to apply this formula 1 over determinant A times the adjoint of matrix A, right? So beside of cofactor, okay, we need to find the we continue with finding the adjoint. Okay, from the cofactor we continue to find the adjoint, where the adjoint is the transpose of your cofactor. Okay, and then beside that we need the determinant. So finding the determinant for 3 by 3 matrix, you have two ways, remember, which is adding two columns at the end, or you can use cofactor method by expanding the row or the column, any row, any column. Okay, okay, please do a lot of exercise to make sure that you are familiar with all these methods. Okay, okay, so for this example, when you calculate the determinant, you get minus 17. Okay, and we have the transpose here. Okay, the adjoint, which is the transpose of the cofactor. So if you choose to transpose the column, it will become the row. Okay, this will become the second row. Third column will become the third row. So this is your adjoint. Okay, and then put all things together and then you get the inverse. Okay, so you can leave your answer in this form, or if you can simplify them, you just multiply it in and then simplify. Alright, so you get the inverse. So I leave the second example for you to try. Next, we go to the second method to find the inverse uh, inverse of matrix 3 by 3. Okay, so the idea is you have matrix A. Okay, you write your matrix A in the augmented matrix like this. This is called augmented matrix. Okay, matrix A beside identity. Okay, so whatever your A is, beside of it is the identity matrix. Okay, depends on the order of your matrix. Okay, and then we will reduce this matrix from A to identity, become identity to A. Okay, where this side will become your inverse. Okay, when we reduce our A here, reduce A here to identity. Okay, from the first form where you have A on your left, reduce it to I, matrix identity on the left. Okay, whatever matrix that changes according to the operation that you perform, this is your inverse. Okay. Okay, in order to reduce matrix A to matrix identity, okay, what I mean is you first have this, right? Okay, then you need to reduce A to matrix I so that on your right side you get the identity matrix. Okay, sorry, the inverse matrix. Okay, when you the process of transforming or reducing A to I will change the I of the original augmented form to matrix A inverse. Okay, so that is the idea. Alright, the process of reducing A to I, okay, you must follow, it is called ERO, elementary row operation. Okay, so it called row operation. So the only um, only the row will change in this operation. Okay, so we will not involve with column. We just change the row. So only row will change. Okay, throughout the process of reducing A to I. Alright. Okay, second thing, okay, in ERO, you must follow 3 rules, okay, for row to change. The first one, okay, you can change row, you can interchange the element between the row. Okay, so you can change row 1 with row 3 or row 2 with row 3, row 1 with row 2. any row, depend on the situation. Okay, for example here, if you have this 2 by 2 matrix, okay, since our target is to get the identity matrix, okay, which is 1 0 0 1, if it is 2 by 2. If it is 3 by 3, our aim is this. Sorry. Our aim is this. Reduce the A until you get this for 3 by 3. If your A is 2 by 2, your aim is to reduce to this identity matrix. Okay. So our aim is always make sure that our first column, first row, first column is 1. So if this is your matrix A, what you can do is you can interchange second column with the first column. Okay, so now row that will change is row 1. Okay, so row 1 will change. So write row 1 first. Okay, it will change with row 2. So you change. Now row 1 will goes up, row 2 will go down. Okay, so that is the first row. What you can do when you apply ERO. Okay. Second rule that you can apply is you can multiply the row with a scalar k. Okay, with non-zero scalar. K cannot be 0. Okay, K cannot be 0. It must be non-zero. Alright, so usually we apply this rule whenever we want to reduce the row to 0. Okay, so we multiply the row with a scalar in order to reduce the im row, okay, to get 0 element. Alright, so for example like this, you can create new row by multiplying the original row by 2 or any scalar non-zero scalar k. Okay, you will see the use of this whenever you deal with the whole process. Okay, so for now I just want to explain the rules involved in the ERO. Okay, last but not least, what you can do is you can add or subtract the ith row to a constant multiply jth row by a non-zero scalar k. Alright, so this is also apply, this rule is also apply whenever you want to reduce the row to a 0, to get a 0. Alright, for example like this, which row do you want to change? You want to change the first row. Okay, so do not multiply anything to the row that you want to change. Okay, so you don't multiply the scalar to the row that you want to change. Okay, so you want to change the row 1, right? Okay, when you want to change the row 1, all the operations that you do won't change the second one. It will remain. Okay, the only row that will change is only row 1. So here, okay, now row 1 will change by adding 2 multiply row 2. Okay, so we multiply 2 to our row 2. Okay, and then we will do addition to this. So our first element we get minus 2 plus 2 is 0. So this is the product of minus 2 plus 2 equal to 0. Where this is row 1 and this is 2 of row 2. Okay, so this one is the product of row 1, which is 3, plus with 2 of row 2, sorry, which is 2 multiplied with 0 is 0, so you get 3. Alright, so we write it to 0, 3, and row 2 remain the same. Do not change 2. The only row that is changing is row 1. Okay, row 2 is changing it's not really change, it's just change in order to find row 1 only. Okay, it's change whenever you multiply 2 with row 2 just to find the row 1. Okay,